So in this lecture, we're going to be talking about the chemistry of life, just jumping right into chapter 2. Um, so let's get into it. So the first question you might be asking yourself is, I thought this was a biology class. Why are we even talking about chemistry right now? And sort of the answer to that is a lot of people consider biology to just be applied chemistry. Certainly, not everyone considers it to be that. There's a lot of ecologists, I think, that would take exception to that. But to really understand how a lot of the processes that we're going to be talking about work, we need to be able to understand their chemical underpinnings. So the reason we care about chemistry is because it's important for us to understand how a lot of these biological processes work. And hopefully you'll see what I'm talking about as we get into it. Also, the principal components of your body, the hydrogen, carbon, oxygen, nitrogen, sulfur, and phosphorus, those are most of what your body is made out of, and those are all chemical elements. And so it should make some intuitive sense to you why you would want to know some chemistry in order to understand fully biology. Also, the four biological macromolecules, which we're going to talk about later, the phospholipids, carbohydrates, proteins, and nucleic acids, those are all made out of chemical elements. Okay, so yeah, you need chemistry to fully understand much of biology. So matter is anything that has mass and takes up space. So most of the things that you are aware of are matter. The computer or phone screen that you're looking at right now is matter. Much of the universe is matter. And what else is there apart from matter? Well, energy. Energy is not matter, so electromagnetic radiation is not matter. Gravity is not matter. Light is not matter. But then you might be asking yourself, well, why are you even talking about this? The reason I'm talking about this is because chemistry is the study of matter and the chemical reactions between substances. All right, so matter, this is something to put in your head. Anything that has mass and takes up space. And chemistry is the study of that matter and the reactions between different substances. So kind of going a level further, the next level beyond just what is matter is what are the elements? And this is probably something that you've seen before. This is a periodic table of elements, and these elements are arranged so that things with similar properties are nearby each other in a particular way, and everything is organized in a particular fashion. And we're going to talk about how this thing is organized and what this all means. But you might be asking yourself then, okay, well, we've talked about matter, but like, what is an element? How is an element different from matter? And maybe atoms is a term you've heard before. How do atoms come into this? Okay, so this is a bunch of gold coins, okay, and gold is an element, okay? Gold is an element. Okay, gold is also certainly matter because it has mass and takes up space. But gold is an element, and what do I mean by an element? What I'm saying is that you can take a gold coin and you could break it in half, and then you'd have two halves of a gold coin, and then you can break each of those in half, and you can continue breaking them in half until you get down to a single atom of gold. So an atom is the sort of like fundamental unit of an element. Okay, so if you have a bunch of gold, which is an element, you can break it down to one atom of gold, and that is the smallest amount of gold that you can have. You can't have any less than one atom of gold, because if you had less than an atom of gold, it wouldn't be gold anymore. So an atom is the smallest unit that you can break an element down into. So let's spend some time maybe describing an element, and then hopefully we can sort of bring this all back together in a way that will make sense. So what's in an atom? What are these subatomic particles, and what makes an element an element? So this particular atom has two protons. Okay, these protons have positive charges. This particular atom also has two neutrons. Neutrons have no charge, or they have neutral charge. And then out here, this atom has two electrons. These electrons have negative charge. And you should notice here that the electrons' two negative charges balance out the protons' two positive charges. So you have two electrons with a negative charge, and you have two protons with a positive charge. That gives you a neutral atom. And what's going to wind up happening is these electrons are actually going to be allowed to move around, and that's going to cause different chemical reactions. The movement of electrons is actually the most important thing for determining what kind of molecules and compounds are going to form, which we will discuss later. But yeah, this is a neutrally charged atom because it has two negatives and two positives. And again, these electrons are sort of floating around the central nucleus here. It was once thought that this behaved kind of like our solar system, where like the nucleus was like the sun and the electrons were moving in these regular patterns around the outside. And that's a great way of thinking about it, but it's not completely correct. But for our purposes, it's kind of good enough for now. Okay, so these are floating around kind of like planets orbiting the central sun. So I had discussed earlier that the number of protons is meaningful. So the number of protons actually determines what kind of element you are looking at. So here we have a carbon atom, and this number here tells you the number of protons that carbon has. It has 6. So the atomic number tells you how many protons there is in an atom. And some different periodic tables will put it in different places, so I want to show you a few different examples. So sulfur's atomic number is 16, nitrogen's atomic number is 7, carbon's atomic number is 6. I just kind of picked these examples at random. The atomic number is always going to tell you how many protons there are in an element. So how many protons does carbon have? Carbon has 6 protons. How many protons does nitrogen have? Nitrogen has 7, because 7 is its atomic number. How many protons does sulfur have? I'll let you guys figure that one out, but its atomic number is 16. So the atomic number always tells you the number of protons. It tells you the number of positive charges that exist within an atom's nucleus. So then the question is, well, what if I had, see, this used to be a 6. What if I had a carbon atom that had 5 protons? What would that look like, a carbon atom with 5 protons? Well, a carbon atom with 5 protons is not a carbon atom. It's a boron atom. You cannot change the number of protons within an atom. Put myself down here. You cannot change the number of protons within an atom without changing what that atom is. So if I had a carbon atom with 5 protons, I wouldn't have a carbon atom at all. You are not allowed to change the number of protons within an atom, okay, or within an element. If you do, you have a different element all of a sudden. So a little pop quiz. It's not really a pop quiz, but how many protons does silver have? You know what? Actually, if you email me, it needs to be very specifically formatted. But if you put in the subject line proton extra credit and write down silver has this many protons. However many protons you think silver has, I'll give you an extra credit point if you just send me that email. But again, it has to be in that specific format. Okay, if it's not in that specific format, you won't get extra credit. Don't email it, or you can email it or whatever, but send me a message on Canvas is probably the easier way to do it. Okay, so that's how you can get some extra credit. And remember, here's the atomic number right here. Remember what that tells you. Let's do another one. How many protons does oxygen have? It has 8, right? Because the atomic number is 8. But what's the deal with this other number here? What's the deal with this number there? Okay, that other number, this one I circled, that other number is the atomic mass. Okay, that other number is the atomic mass. And what the atomic mass is just the number of protons plus the number of neutrons in a particular element. So you already know how many protons it has, right? It has 8, because if it had 7, it would not be oxygen anymore. It would be nitrogen, right? So we know that this atom of oxygen has 8 protons because it's an atom of oxygen. So then how can we go about figuring out how many neutrons it has? We know it has 8 protons. How many neutrons does it have? Well, we know that the atomic mass is 16 for this particular atom. And I've told you that the atomic mass is equal to the number of protons plus the number of neutrons. So it has 8 protons plus the number of neutrons. So we know that 16 is equal to 8 plus the number of neutrons. So with just a little bit of algebra, you subtract the 8 across both sides, you get that 8 is equal to the number of neutrons. So, but you might be asking, why is the number on the periodic table itself a fraction? So I showed you like this 16, but what you'll see on the periodic table is actually 15.999 repeating. And so why is it a fraction? Because you can't break down a proton. You can't have half a proton, and you can't have half a neutron. Okay, and those two things are what determine this number. So how is it that you have 15.999 when you can only have one proton and you can only have one neutron? So the answer to that question is isotopes. There's this thing called isotopes. And so what is an isotope? Let's talk about it. So here are 2 different isotopes of carbon. We already know their atomic number is 6 because it's carbon. That means that it has 6 protons. Okay, but here's an atom of carbon that has an atomic mass of 12. And here is an atom of carbon that has an atomic mass of 13. So how many neutrons do we have on this left carbon? Well, we have 6, right? Because it's an atom of carbon. So how many protons do we have on this right carbon? And this might be starting to sound redundant, but it has 6. Because it is an atom of carbon, and that is the definition of carbon, is that it has 6 protons. So we know that it has 6 by definition. How many neutrons does each of these have now? The one on the left, how many neutrons does it have? Well, you know that it has 6, because this number, this atomic mass number, is equal to the number of protons plus the number of neutrons. So we know that this one has 6. How many neutrons does this carbon-13 have, on the other hand? Well, it has 7. Same logic. 13 is equal to 6 plus the number of neutrons. So this has 7 neutrons. And I'm sure, even though we've puzzled this out, I'm sure you noticed we haven't actually answered the question yet. Why is there a fraction here for this atomic mass number? How is it that you take 2 whole numbers and add them together and get this fraction? How do you take, a whole number of protons plus a whole number of neutrons and get the fraction? Well, the answer is because this number is an average of all the isotopes of carbon. So they went through and they have figured out every single isotope of carbon, And they said on average, your mass of carbon is 12.01. So that means most carbon atoms have 12 neutrons, but there are some carbon atoms out there that have 13. So let's do a quick review of everything we've talked about so far. Chemistry. Chemistry is the study of matter and chemical reactions between different substances. Matter then is anything that has mass and occupies space. And the universe is basically made out of matter and energy without getting too deep into the physics. An element is something that can be broken down into a single atom and still have the same properties. So if you have a whole bunch of gold, you can break it down, theoretically, you can break it down into one atom of gold, and that one atom of gold will still have all of the properties of gold. If you get any smaller than that, you start to change the properties. So those are atoms. I'm sorry, those are elements. And an atom then is the smallest thing that you can break an element down into. Atoms are made up of these subatomic particles, protons, meaning positively charged. Protons have a positive charge, and protons exist within the nucleus of an atom. You also, in the nucleus of an atom, have neutrons, which are neutrally charged subatomic particles. And you have electrons, which exist sort of around, they sort of float around the central nucleus of an atom. Electrons have a negative charge. Remember, we have the atomic number. The atomic number tells you the number of protons that you have within an atom. We have the atomic mass, which is equal to the number of protons plus the number of neutrons in a particular atom. And then we have isotopes, which are atoms with different numbers of neutrons in them. So carbon-12 has 6 neutrons. Carbon-13 has 7 neutrons. And the difference in the number of neutrons is going to cause that atom to have slightly different properties. So carbon-13 is what's called radioactive, and carbon-12 is not.